Hello everyone, this is Mathematics and we are here with the last section, or rather say section 2.5 of chapter Quadratics, which is Discriminant, the most important section of the whole chapter that will be used once in the real exam, and the question that you're going to use it for is going to be hard. The topic discriminant is going to make it very hard. So let us see what makes it hard about discriminants. So guys, for quadratics, ax squared plus bx plus c equal to 0. We had a formula, right? We had x equal to b plus or minus root b squared minus 4ac divided by 2a. So guys, I have a question. So sometimes some of the equations do not have a real root, or they have a repeated root. Well, so I suppose it has to do something with this part of the equation, this part of the expression. So yes, you guessed it right. We call b squared minus 4ac the discriminant. Okay, and for b squared minus 4ac, guys, we have three possibilities. Okay, we have three possibilities. Either b squared minus 4ac is greater than 0, b squared minus 4ac is equal to 0, or b squared minus 4ac is less than 0. So what happens in each of these cases? Okay guys, first of all, let me define a function f of x, which is equal to ax squared plus bx plus c, where a is not equal to 0. A is not equal to 0. So in this function that I have defined, how am I gonna deal with the discriminant? So guys, can you remember the roots of a quadratic? F of x equal to 0. The answers for x for which f of x is going to be 0. So roots are the values of x for which f of x is going to be equal to 0, right? So, and if I have my sketch, right? If I have my sketch, let's say that a is greater than 0, right? So I will have a minimum point. But wait, here it has two roots. But I have another possible sketch. I have this one as well, where it touches the x-axis at one point. It doesn't intersect it twice. I also can have this one that doesn't have anything to do with the x-axis. Here it is the x-axis, right? So in each of these cases, they all go back to the discriminant, guys. Okay. For me to have a better clarification for the sketch of the graph, let's say this one is a is greater than 0. So guys, if you have b squared minus 4ac greater than 0, it means that for f of x equal to 0, which is ax squared plus bx plus c equal to 0, your answers for x will be minus b plus or minus root b squared minus 4ac divided by 2a. And if b squared minus 4ac is greater than 0, then you're gonna have two distinct real solutions for x. Or if I'm gonna make it simpler, you're gonna have two values of x for which the graph of f of x intersects the x-axis. So if b squared minus 4ac is greater than 0 and your a is greater than 0, then your graph will be something like this. Y, x. Your graph is going to be like this. 1 root, 2 roots. Why? Because b squared minus 4ac is greater than 0. And the square root of this can have two distinct values, right? One is going to be positive and one is going to be negative, which when you put it in the formula, you're gonna get two distinct values of x, right? So we go to the next possibility. b squared minus 4ac equal to 0. Here, guys, we know that x is going to be equal to minus b plus or minus root b squared minus 4ac divided by 2a. But guys, we are said that we are given that b squared minus 4ac is equal to 0. So this is going to be equal to 0, right? So x is going to be equal to minus b plus or minus root 0 over 2a. But root 0 is 0 and plus 0 is 0, minus 0 is 0 as well. They're all 0. So you're gonna have one repeated root. And when you have one repeated root, your graph is going to touch the x-axis once, right? So for a greater than 0, your graph will have a shape which is like this. See, it only touches the x-axis once. And if you have, in the third case, if you have b squared minus 4ac less than 0, then you'll have x equal to minus b plus or minus root b squared minus 4ac divided by 2a. But guys, I have a question. Didn't we say that if a number, or rather say the radicand under the square root, if it is equal to a negative number, or rather say it is less than 0, then it will have no real answer? Didn't we say that? Yes. So how am I gonna do that? You have no value of x. You have no values of x for which the graph intersects the x-axis. So the graph will not intersect the x-axis at all. It will not intersect the x-axis. Why? Because x equal to minus b plus or minus root b squared minus 4ac over 2a will have no real answer. So for a greater than 0, your graph will have a shape like this. See, it neither touches or intersects the x-axis. And this is how you do it, right? So let's say we are going to solve example 14 on page 31. Let's do the example. Find the range of values of k for which x squared plus 4x plus k is going to be equal to 0. And this one is going to have two distinct real solutions. Guys, when you are given two distinct real solutions, it means the discriminant is greater than 0. If you were given that it has one real solution, then you knew that b squared minus 4ac is going to be equal to 0. And if it had given you that this has no real solution, then you knew that b squared minus 4ac was less than 0. So in this case, we have two distinct real solutions. So b squared minus 4ac is going to be greater than 0. So here, your a is going to be equal to 1, your b is going to be equal to 4, and your c is going to be equal to k. And b squared minus 4ac becomes 4 squared minus 4 times 1 times k, greater than 0. So 16 minus 4k is greater than 0. So by solving the inequality, you know that k is going to be less than 4. And this is your answer. However, guys, the questions for past papers, they combine the questions of the discriminant and the equation of the straight line to make it harder for you to solve the question and solve for the range of k. And they use the discriminant rule for it. So that's why we said that earlier. The discriminant is the most important section of this whole chapter, and you have to master it very well. So when we get to the equation of the straight line and when we get to the past papers, we will solve those questions together, and you will see that how we can solve those and how easy they can be while confusing you. So this is it for chapter 2, guys. Quadratics are finished, and I see you for the next session. Bye, guys.